So, hello everybody. I hope you had so far a wonderful day. I hope I won't ruin it now by introducing you to some pain with Gradle and my little journey to what I want to present now. So, short notice to me, who I am. My name is Matthias. I'm living in a small village, you might have heard of it, in Germany, called Berlin. I am currently an Android engineer at Lichtblick SE. Lichtblick SE, you don't need to memorize this company. We are just the oldest green energy provider in Germany. We are not that big, not that important. And I'm really into Kotlin multi-platform when I have free time. And I'm actually also doing Rust in the rest of my time. And I'm also organizing free meetups, which is actually the Kotlin user group in Berlin, the Rust meetup, and because I'm super bored, I also do the Extreme Programming Club in Berlin. Hooray, right? And if you want to reach out to me, that's easy to find me because my handles are always the same. It's either Bitpogo or just my name. So easy. And if you are not on Kotlin Slack, please join. That would be great. Anyhow, let's go on. So which problems I want to address? First of all, what we want really with whole setup and stuff is to make it easy, right? We don't want to repeat stuff like SDK numbers of Android. We don't want to repeat stuff like setting up certain dependencies and so on, because it's simply boilerplate, which we can normally avoid, right? So what we also want to be, we want to be lazy. That's the consequence out of it, right? We don't want to put effort in such stuff. We just want to throw a plugin or something at it and just be done with it. That would be great because that just means one string, we are done, and not a pile of setup we have to do. And what else? Why I'm doing this talk? Because I love elephants for sure. But yeah, sorry, I ended up with a Gradle talk and want to embrace that Gradle is now, since it recommends officially Kotlin as language to develop in, part of the Kotlin ecosystem, which is great. So because if you know, we started at some point with Groovy, and if you ever develop in Groovy, if you are super smart, you will love it, right? I'm not super smart, I hate it. So let's start with version catalogs. So what we want to solve here, first of all, we want to solve how we can actually distribute dependencies over multiple projects, right? Without even copy-paste stuff. That's because copy-paste is always error-prone, and maybe we have there forgotten something or have to adjust there something that's just worse. So what else we want to do? We want still have the capabilities to alter Snowflake dependencies for Snowflake projects. Like maybe you have to use a certain version for a certain project for a certain dependency, and that's really annoying. That's the really annoying part, right? If you ever had been there, just because you need to do that for whatever reasons, and you can't do that with the normal approaches, I will help you with this talk, I hope, at least. So, and another thing is that we want to, with dependency updates, also avoid breaking changes, right? We want to make sure that our dependency is working. We just want to distribute them, hook them in, and amazingly, everything works. That's the dream, right? So, and as I mentioned at the beginning, or when I started with Kotlin, that's not so long ago, and now my thingy didn't want to, you might remember extensions and Groovy, right? So just to give you a little reminder, you normally do something like with a build script, and there you put extensions into it, which you then hook into some dependencies. Like here you have the extension, right? Here you define a version or a name for a version. You put the version in here, and here you have the entire dependency with the version. Boring shit, but yeah, well, you can do that further and having a little bit more structure if you want to actually combine some dependencies together, some versions. That's possible with that as well. But I skipped it here because it doesn't look nice. Let's put it nicely. So, and then we also can consume it in some random part somewhere in our application by simply use application implementation, right? We then also make our hard-coded dependency again with our version, which is in this example just our Kotlin version, which is pretty old. So it's not really shareable, right? It's everything hard-coded. If we want to share it, we have to basically copy-paste everything, and that's not great. we can't not really versioning our dependencies, and we need versioning to avoid breaking changes, for example, because if we, for example, introduce accidentally a breaking change, we cannot simply roll back. We only can do that via version control, and that's not great, because you never know when actually you sometimes encounter a breaking change on your dependencies. That might be much, much later after you introduce actually an update or something, right? And auto-update works not so well with that. If you ever use something like Dependabot or Renovate, it works if you put a little bit effort in the configuration, but it doesn't come for free out of the box. That's not great. So, and there are more stuff like, as I said, the syntax is not so well. You have to do a lot of magic, especially with Groovy. I don't really like Groovy, but that's just a personal taste, right? And the next evolution step is then that we might ship our dependencies in something like include build or a small plugin, or via build source, which then might be looked like that. You might recognize this little folder here, and then you can simply write a version object, a singleton, which contains maybe a version for coil, and then you can simply define that, which I actually highlighted here much nicer for you. So there we have the version, which we actually bind here. There we have our entire dependency as a string. And here we have the nominator, which we then consume somewhere in a project like this. We have implementation again, and then we just refer to the object we built actually here, which would be dependency. Right? It's much nicer because now we can start to actually structure our code in a very programmatic way, which is lovely. We also can think about how to ship it because we simply can wrap a plugin around it and put it on Maven Central or wherever you want to publish that, maybe Artifactory, and just consume it in other projects. That's possible. But, so I said that, sorry, I just need to scroll through the slides. Yeah, we can version it because when we ship it, that means still we can have different release artifacts, which in themselves are for sure versioned. So we can roll back easily, which is nice. And we also can do more complex rules, which means, for example, if you want to introduce some programmatic dependencies, which are depending on some side effects inside the project, you can actually program that via this approach because you actually have a program there. You have actually a Kotlin object, right? So you can do whatever you want with it, which is great. And now we are at the but, right? We cannot overwrite versions in the plugin. Like, for example, here, we would not be able to replace this version here. So let me scroll forward. Sorry, that takes a moment. So what we also can not really do, we can not say, for example, for transcendent dependency, like please use the Kotlin version for that via this way to propagate dependencies. And we also cannot add project-specific dependencies or making some modifications for the dependencies for a specific Snowflake project, right? So if I say Snowflake projects, it's always the special cases, you know, just, yeah. And updating works, but it is still an issue. So, and there's more, for sure, as always. But there is a thing which you might have heard of. I hope you already tried it, which is a version catalog. And that thing is amazing because it solves a lot of issues. You might recognize this. That's a very special format for a YAML file. It's called TOML. This format is also used, for example, for Rust, if you're defining their stuff. And the good thing is about that, it's very clear structured with very clear blocks, which we shortly go over. First of all, we can define versions in our version block. You just have this kind of tag. Then you have the denominator as here, and you put a version. So it's an older Kotlin version because it's from an older project, or the talk is a little bit older, these slides. So in the next block, we can actually define dependencies, which is under this library thing here. So we put a denominator as well, is that thing here. And do you see the yellow dashes, right? That's important because the yellow dashes are the separator when Gradle then composes out of that the dependency object. So you would have then something like maybe libs.android.appcompact.core. So just as a small aside, And then you put here your module dependencies. There's also an alternative notation, which I put you in the comment above. And that's also very interesting. You can reference a version via a string. And this version reference goes back to the version tag here above. Okay? So next block. We also can define here plugins, which is also great. So same as before. We just have a denominator, right? Android something something. We also have here this dash thingy as before. We put the ID of the plugin here, right? And same thing with the version. We have a reference with a string, which links to this version block above. Easy peasy is that, great? So, and there's a feature which I really love and which is, I think, very underrated, is bundles. So, because in bundles, you can bundle stuff together. And that's happening very often, for example, if you use Compose or if you use some testing frameworks, you always use over and over the same dependencies. Why not just bundle them together in a bundle, which you can do here? And what you basically do is also you have the dash, you have the denominator, and then just making an array of your dependencies and the names in this array going back to this library tag above. Easy, super easy, love it. And the next thing you can do, that's optional, you can even give them a name, a normal name, like not the convention name, because by convention, version catalog is under the Gradle folder on your root project. And when you are putting it there, it automatically does some magic and you find a dependency or you find at your project attached this libs.something something, right? But you can also make a custom hook, which is going via this dependency resolution management blocks in your settings file. Then you say, oh, I want to modify the version catalogs, and you just create a new one with a name, right? And you have the create hook, which creates one. That's very telling. And then you only say where to find it, right? Which would be, in my case, under Gradle and antibytes, catalog, toml. So easy as that. It's also very pretty straightforward. And we will abuse that thing for some stuff because we can. I love abusing stuff. So, and another trick is if you if you just want to rename a default name of this libs.something something, you can also in this dependency resolution tag just use that thing here and set a new name. That's basically it. And then it compiles to this name, not libs. It's just for more readability or if you want to brand your version catalog to your company or whatever reasons. There are enough reasons to have a proper naming there, which is not just libs, right? And also, just a tip, if your version catalog gets too big, that's the way you can split it. If you're working with different teams, that's the way you can actually split them between and combine it from different teams, right? Via this creation hook here. Just that you are aware of that. Anyways, and easy peasy is that. For example, we defined a publishing plugin. We then can easily hook it in somewhere in a build file via alias, which resolves the plugin name, which comes from our version catalog, which we called earlier antibytes. Then we have this plugin block, which you might remember now from the toml, and then you have the signature from the entire plugin. And here you see the dashes resolve to dots, right? Easy peasy is that. And same goes then for normal dependencies, same. You have the version catalog, name, you have the dependency, the dashes go to dots. That's it. And same goes for bundles. And you can refer to the bundle name. That's it. Easy. So next. What we want to do is then to publish it, right? Because we want to share it maybe with different projects. And here again, you could maybe ship it to Artifactory. You can ship it via GitHub. You can ship it via Gradle Plugin Portal, whatever you want. Just ship it. And that's pretty easy because it's almost the same like you would normally ship something. First of all, you need the version catalog plugin, which just tells here is a hook where you find the version catalog. We come to that later. Then you need for sure, there's a highlighting. You need the Maven publishing plugin, which you then configure. And that's optional. You can also sign that. If you, for example, publish to Maven Central, that's mandatory, you have to sign it. But if you have your own stuff, you don't need it, right? And that's also very important. If you do that, you need to create a custom component, which you do over the create hook. Sorry, I'm super weird German sometimes. Create hook in the publishing thing, and you then just say you have a custom component which is coming from a version catalog. That's it. So, and as mentioned before, the version catalog enables you then that you can say, oh, here under catalog you find under that file a version catalog which I actually then want to ship. That's it. So pretty boring, pretty easy. And that's good that it is pretty easy and boring, because that means no fancy stuff we have to take care of, right? Love it. So what else? So can we then, when we on the consumer side, change versions and stuff? Of course we can, because as I said, version catalogs are amazing. And that's just a small example. We go through that right now. First of all, we have to find our version catalog. Therefore, is that get by name, and we have the name of the version catalog, right? So we have the version catalog now, and we can overwrite a version just by simply using the programmatic API, which exposes this version thing, or this version function, where we then say, oh, this Gradle KSP plugin dependency gets now this version. And simply as that, you have overwritten it. That's it. So you can also add new dependency by just using the library function. Same as before. You add the name, then you add maybe the group, you add the artifact name, and the version reference. So, and you also can add here new versions, right, via versions. So, and lastly, you can also add new bundles and plugins. Same as before, boring, which is good, because boring means it's easy. Love it. So can we abuse it? That's the interesting part. Because for me, it's like, I want to do a Kotlin multi-platform. So that means for Kotlin JS, I need node dependencies. So, and node dependencies are normally not shipped via a TOML or anything, right? I need somehow to do something there. And yeah, we can define some node dependencies in our version catalog. So you don't need to care about that. That's just a convention, and that's just an idea to tease you. How you want to implement that, that's completely on you. So, and then what we do is actually extending the Kotlin dependency handler, which is actually used in this dependency block. So, and what we actually introduce is this new function, which we call node production package. So, and what we get in the dependency block is a provider, which has this minimal external module dependency, which means that's coming from Gradle, which simply packs the dependency and has a clear structure how it's built. And then we can do something with the provider because we have access to it, right? We can just get it because provider are lazy and then run something on it. And that we do in the next part. We just then said, oh, here I have a dependency which is resolved by NPM, and whatever here is happening is not so interesting because it's just the idea how I structure that. But for example, if you're working with Kotlin JS, you could do something similar. Or if you want to ship some Python dependencies, you can do something similar. Or in my case, I also use some Rust dependencies and I make exactly the same. So, and it's, again, it's easy to do. You just have to tinker at some places and that's it. And it's easy, it's boring, great, love it. So, and then we just can simply hook it in. That's what I said. We have now this node production package thing. We can use our version catalog with our node Axios package, and that's it. Great. Can we do even more? Of course we can, because the worst, or what we want to have is confirmation that our dependencies work, right? And actually, you might already know that how maybe cross-check your dependencies right now, because that's super easy. We already know we can simply create a version catalog in a project, and the only thing we have to do is just tinker a little bit with the path, so that we on a local project just adjust our dependency catalog to a different path where our actual dependency or version catalog is registered, and then can just check if our program or our library is locally working with the updated dependencies without having to first publishing it, then download it, and all the trouble. That's super easy because that takes you maybe a minute or 2 minutes just to verify. Love it. So just to summarize, vision catalogs are super versatile. You can do a lot with the programmatic API. You can program with that because that's is it meant for, right? And yeah, you can also develop very complex stuff. I did that, for example. I have built for myself an entire toml builder, just that I can do weird stuff like with Rust dependency, as I mentioned. So, and we can share non-JVM things and more. Boring. So, what else we can do? We can ship our setup, and that's super easy as well. And what we want to do is distribute configuration over projects, right? Simply for the sake of reducing boilerplate. So, and also we want actually to keep our build files clean and small, because smaller build files mean we don't have to scroll and don't understand what's actually happening there anymore. And maybe there are some side effects which is coming from the root project and you don't know what's there, and that's the worst. You just want a small build file which contains or is self-contained. So, and sure, we want to reduce the effort to a bare minimum. So how we do that, that's easy. We just build a plugin. And I just give you a brief introduction into that. That's not exhaustive, just very short. What we have to do is simply following. We build a plugin, which in this case we might call my plugin, and just extending from the plugin interface, and that gets a project. So that means then we have to override apply, and apply has then in its signature as an argument project. And project is that what you have in your build grade file. And since we then have actual access to that object, we can configure everything. We run already at this point. And I don't have here to fill in the blanks because you know better what configuration you want to put in than me. My configuration will look completely different from yours. And we can do even more. We can actually make our configuration plugin configurable by adding some extensions. Extensions is what you normally see also in Gradle when you, for example, have the publishing plugin, and then you have this publishing hook, which appearing out of nowhere. That's done in Gradle via extensions. And the easiest one, you can just build an interface. Like here, oh, here it's better. You have an interface, and that's it. You're done. You can just define stuff you want, and you should use actually property, because that's resolved lazy and not directly something like your configuration object, which would be in this case, I just used that from a Lynda project, this Lynda configuration object. If you want to set some defaults, you need to do a little bit more, which is this abstract class thing, which then extends the interface, and you can just set a default value. That's it. And then we hook it in our plugin, right? So via this, we have to go over the project. We have to register it there, which is coming from here via extension create. Then we have to set a name, which is here, and point to the class where our extension is actually defined, which is here. That's it. So, and that's just an example how such a thing could look in all its glory. That's a small quality plugin I use for my projects. You don't need to know what's happening there, just that you see you can do something with it. That's all. You have to fill in the gaps, not me, because your projects. So, and how we actually distribute that, we need a plugin for plugins, which is here, right? This Java Gradle plugin. Then we get access to that Gradle plugin block. Then we have to register our plugin with a plugin ID. That's what you then use at the consuming side. You will see that in a moment. And you have also to point to the implementation class of the plugin. That's it, easy. And here we then consume the plugin with our plugin ID, which we set before here. So that's it. And then the plugin is exposed. If you share it via something like Maven Central, of course, you have to set a repository to find it, and you also then get access to your extension. That's it. You can do then everything you want. So that's what I already said. Yeah. For example, what I also like to do is writing meta plugins. So, for example, you have something like Spotless, you have something like Detect, you have something like Katie Lind or whatever. Just put a plugin over those plugins just to apply them, because you will do that for every project again and again and again. Makes your life much more easier. And since you can publish it, you can also version it, which means you also can avoid breaking changes. Yeah, and you can share with any project, even if it's not yours. If you are working for an agency, for example, and you want to make your customers much more happy by still having control over their project, you can simply publishing your version catalog and your plugins and just hook it in their projects, for example. So can we also use your plugins on your local project? What I mean with that is you have a project which has a plugin, and for example, your publishing plugin, you want to use the publishing plugin in your publishing plugin. You can do that. We just use composite builds over that. And can we do something more? Yeah, that's what I'm basically saying right now. What we do is actually simply we symlink our stuff in a different project or a sub-project, which is happening here. That's the indicator that is a symlink here and here. That's all the dependency I need for this quality plugin. So many plugins in one sentence, amazing. And then we simply use included build, aka composite build, to just use it, and we can apply it. Done. So, and can we do more? Can we have something like a plugin to ship our version catalogs and hook it already into our projects? Yes, we can, because we are amazing. So what we are doing is just another plugin. It's awesome, so many plugins in one sentence. But this time, it's not a project plugin, it's a settings plugin. So as you can see here, we have a dependency, my dependency settings plugin, which gets settings, and settings refers to your settings Gradle file, just that you connected in your mind. Then we get access to that, and then we set in our dependency, then we gain access to our dependency resolution management, which you might recognize from earlier, and then we can do stuff. Oops. Then we can do stuff again. Like, first of all, of course, we have to hook in our repositories where we get our stuff from. That's easy. And we can apply our version catalog. So we can hook it in. Done. So, and the amazing stuff is your settings Gradle file looks in the end like this. So you have just to modify here your plugin management, where you point to the repository. I highlighted that, where you point to a repository where your actual settings plugins lives, and then you just apply it, and you have a version which you can then also bump, which means you can easily just change a string and have effectively an entire update of your dependencies. Isn't that amazing? And you can also refer your configuration plugins in the version catalog, so you ship everything at all. And we are done, basically. We can even ship something like your detect config YAML, but I won't show you that because I'm already out of time. I'm sorry. So maybe another time. So what we have gone so far, we looked at many configuration stuff. We can sorry, I got a little bit lost with my clicker. Yeah. What I showed you is that you can easily configure your project over one thing. First of all, you can share your dependencies in Gradle, which is actually very good and very easy, very boring. And boring means actually very good. And you can just, by simply bumping one string, update your entire project. That's it. And sorry, 30 minutes are very short to demonstrate you that. So, and I would love, if you have feedback to that little talk, just scan that small QR code. You will end up on a Google form, and just give me some feedback, because it's important for me to improve. And, oh, I'm too fast, right? I should call 1 Mississippi, 2 Mississippis, 3 Mississippis.